So this is the first problem of the contest. We got everything covered. In the problem, we have been given two positive integers n and k, and our task is to find out a string s such that all the possible strings of length n that can be formed using the first k lowercase English alphabets um, occur as a subsequence of s. So what we are being told is that we have two integers n and k. N denotes the length of the strings, like we will see what it is, and with this k it denotes the first k alphabets of English lowercase English alphabets, lowercase English alphabet. So it is like a b c d. If k is 2, it is talking about considering only first two elements, first two characters. If k is 3, it is talking about considering first three characters. And we have to print a string s. We have to print a string s such that, let's say I print our string like ABC, just this much, and n is equal to 1. So what should happen is all the strings for k equal to 3, all the strings which can be formed with the first three English lowercase alphabets, that is A, B, and C, all those strings of length 1 should be coming up as some subsequence inside this string s. That's what the problem says. Let us see this thing once more in a little more clearer way. You will be given some integers n and k, and for the integers n and k, you have to output a string, let's say string s, such that all the strings which can be created from the first k lowercase alphabets, let's say if k is something like 4, then all the strings which can be created from the alphabets a, b, c, and d of length n, if in case length n is 2. So all the strings like AB, AD, DA, DD, like DB, DD, all such strings of length 2 being created, like having characters, having only the first four characters. All this kind of strings should be coming up as a subsequence in the string which we output. So is the problem clear? It might, I think it is a little harder than what generally comes for the A problem. So guys, is this problem clear? Like the problem statement? Okay, great. So we have to find such string s. Now this problem is kind of a constructive problem where, like, not a standard problem, but you have to think of some pattern, maybe find some pattern or something like that. So what we generally do is at like for this kind of problems where you have to think of some pattern or something like that, we go for the example test cases and try to look up if we get some hint from it there. The first example test case shows you this thing. The string is AB. Like we don't really get much hint from here, neither for the second one. But for third one and the fourth one, we can get some hint. You see one thing? The first two characters come first, and after that, the next two characters come together. Like when n is equal to 2 and k is equal to 2, what do you want? You want to cover up all the strings like AB, AA, BA, and BB, right? For all these strings. So what you want is the first character can be anything, like any one of A or B. The second character can be anything A or B, right? Right. All the strings. I want this kind of strings that the first character can either be A or B. The second character can either be A or B, because that's what happening here, right? All this kind of combinations. If just imagine that n was equal to 4 and k was equal to 3, then what kind of strings do I want to cover? I want to cover the strings in which the first character can either be A, B, or C. The second character can either be A, B, or C. The third character can either be A, B, or C. The fourth character can either be A, B, or C. I want to have this kind of strings coming up as a subsequence and like of some string. Basically, I want my output to have all this kind of strings as a subsequence. Now, if you had been trying to think about this kind of way for the problem, or had been just looking up at the example test cases very hardly, then you might have noticed this pattern, that what if I keep something like A, B, and C at the first place? Then after that, I again keep A, B, or C, or like in any order. Then again A, B, C in any order. Then again A, B, C in any order. Now, whatever string I want to have of length 4, to, let's say I talk about a string like BACD. Sorry, first three characters, BACA. This kind of string would be coming up in this string as a subsequence, because the first character you want is B. So you can just pick up the B from the first three characters. Then you want A, you can just pick up A from these characters. Then you can pick up C, then you can pick up A again. And this is kind of a pattern which we noticed. Now, um, it might come up very early in your mind, or it might take up some time. But I believe that if you have tried to think about patterns for this problem, you would have eventually got to this kind of a pattern, that just have the first key characters coming up. After that, after that you are having another key characters coming up together. Then another k characters, another k characters. In that case, all the possible strings of length 4 with built up with the first k English alphabets would be coming up here as a subsequence. Does this thing make sense? Man, there is no sliding window inside it. So yeah. Okay. So guys, does this thing make sense? Like, do you get the intuition of how we could have um, got to this thing? Uh, like, it's kind of random. It's not completely a standard thing that you could definitely get up to this point. But eventually, you would have got this kind of a pattern if you just had been trying to think of what kind of strings there could have been. Okay, so should we move on to the code and then the next problem? Or is there anybody having any doubt regarding this problem or regarding the intuition of this problem? We are discussing C or A? We are discussing A problem right now. Okay, so let us see the code for the problem. What I did here is, you want me to repeat once again? Let me repeat. Let me tell you about the problem again in brief. So what happened here is, we were being given some integer n and some integer k, and we were being told that we want to find up a string, like this should be a string s, in which all the possible strings, of of length n, or maybe you can say k n characters, where every character is one of the first k English lowercase alphabets. Um, all such strings should be coming up as a subsequence of the string s. I have just said the problem in some different language in this time, that you could have said the problem in this way, that you are being given two integers n and k. You have to find a string s such that all the strings of length n, which are built up by some alphabets from the first k English lowercase alphabets, all such strings should be coming up as a subsequence of the string s. Now, what are these strings? Now, what are these strings we are talking about? These strings are nothing but strings like, let's take an example. If n is equal to 4 and k is equal to 2, then the strings like AA, BA, or ABAB, or ABBB. Basically, there are four characters in the string, and all the characters are either A or B. Basically, the first two lowercase English alphabets. All this kind of strings should be there in the string s as a subsequence. So from here, you could notice one thing. For these strings, the first character can either be A or B, A or B. The second character can either be like A or B. Similarly for third character and similarly for fourth character. They can either be A or B. And from this point, you can get the idea. This can just come up in your mind that what if I take AB, 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 this as my string, this as my string S. In that case, all such substrings, if you talk about AABA, A, A, B, A, all such substrings will come up in this string as a subsequence for sure. So Mayank, does this thing make sense now? Okay, so here is my code for this. Yeah, by the way, one more thing. Even if you had written BA here, it doesn't really matter. The answer would still be correct. The idea here was that the first two characters coming together, then the next two, then the next two, and then the next two. This thing should hold for sure. Even if you have something like A, B, B, or maybe A, B, A, something like that coming up, it doesn't really make any difference. The main idea is that there should be some blocks. There should be n blocks such that every block has all the first k characters. Now, the thing I have said you at the end of thinking about it as blocks is something it would be helpful in the third problem. You don't really need to think that much for solving the first problem. So someone is asking, so what is the problem if we print ABC up to k characters? A, C, D, N. Adbhut, I think that we can discuss this after the session. Right now, I didn't really understand it properly. Oh, this one, I think now it's in 3 rounds. Okay, so good enough. We have got how to solve the first problem. Here is my code. For every test case, I'm first of all taking n and k as input. After that, I'm saying that, hey, go on n number of times, and every time just add all the first English alphabets to your string, which I have named as answer for now, and then I'm printing answer. So just in case if you don't really understand this part, it is nothing but we are saying that the for the character A, add J. Uh, I'm telling this for those people who don't really know about it right now. Character A plus 1, if you say this thing, and then like it becomes an integer for now, and if you typecast it back to char, it will return you character B. And similarly, if you had said that add 2 into character A, in that case, it will become character C. So if you guys know about this thing, then it should not be hard to understand this now. Okay, so let's move on to the second problem. I hope that this one is clear now. So this is the second problem, a balanced problem set. In the problem set, we have been told that, in the problem, we have been told that Jaya managed to create a problem of difficulty X, like this is some story. So basically, he managed to create a problem of difficulty X, but the problem X might be too difficult. So he decided to break it up into n subproblems with difficulties of each subproblem as some positive integer, and the sum is equal to X. And the coordinator defines the difficulty of the problem set as the GCD of difficulties of subproblems in the problem set. And we have to find the maximum balance that Yash can achieve if he chooses the difficulties of subproblems optimally. Okay, so the subproblem has, the problem has been written in a little complicated manner. Like they have just written some story to make it look a little complicated. The thing is simple. Let me tell the same problem in some simple words. The problem is you have been given some integer x and some integer n, and you will say, like you will break this integer x into some n numbers, such like something like this, x1 plus x2 plus so on till xn, you will choose some n numbers such that the sum of all of these is equal to x, where x1, x2, x3, and so on till xn are all positive integers. Like all of them are positive. It won't be even one. It won't be even equal to zero. It would be at least one. This is the problem. And what we want to have is we want to find out what is the maximum possible value of GCD of x1, x2, x3, and so on till xn. This is the thing which we want to find out. Maximum possible value of this thing. If we choose these x1, x2, and numbers till xn optimally. So guys, does this thing make sense? Like does the problem make sense? That what is the problem? If you see, whatever they have written here is nothing but only this content. This is what they are saying in some a little complicated manner. Okay, great. Let's look at the examples. 3, 10, 3. So the first example is x equal to 10 and n equal to 3. You have to divide this 10 into three numbers. Let us see what we could do. We could do something like 1 plus like 1 plus 1 plus 8. No, these are three numbers. Then what would be the GCD of these three numbers? Guys, please write in chat. What would be the GCD of these three numbers? It would be 1, right? It would be 1. Something like this. This is what we could do. Now we have to decide on what like how should we choose these three numbers, and we want to maximize this value. And whatever maximum value which we can get for this point would be our answer as well. So here, let me show another way. You could say something like 4 plus 4 plus 2. Here you will have the GCD of 4, 4 and 2. It will come out to be 2, right? This is another thing. So I know that answer is at least 2. I have at least found up a way of getting the GCD equal to 2, right? So is the problem clear now? I took this example just for the purpose of getting the problem cleared. We have not talked about any intuition for what to do. Okay. If this problem is clear, now again, we don't know how to choose these numbers, right? We don't have any idea about it. But we know one thing for sure, that we have to find some pattern or have some logical thing here. So one thing is clear, looking up at the test cases will be beneficial here as well. You will generally see that for the first three problems, specifically for the first three problems, they design it in such a way that even if you don't really get much idea by looking at the problem statement, you can look at the test cases to get some big hints. As an example, the hint I got from the example test case here is this one, 4269. Sorry, 420 and 69. If x is equal to 420 and n is equal to 69, what can I do? In what numbers can I decide? Can I divide this 420? So one question I had in my mind is, for 69, I don't really know what to do. I just know that the answer would come up to be 6, but I don't really know how they did this. I know. Can I make the problem simple for me? Can I make the example test case simple for me? Just assume that if it was 70, that is the thing which I did. Here, if you notice this, I didn't really have much of an idea of what to do when x was 420 and y was 69. But when I thought of making n equal to 70, it became easier for me because now I know that 70 divides 420. So one of the things I can do here is just have 666 everywhere, 70 number of times, right? And if you try to think about it, like this thing can be proved that x by n, like when n divides x, for the case where x mod n is equal to 0, in that case, you can easily get x by n. है ना? You can easily get the answer by x by n because you can just have all the values equal to x by n, x by n, x by n again and again. Here, x by n is equal to 420 by 70, that is 6. So you can just have x by n, that element coming up everywhere. So the GCD can easily be x by n. है ना? This can easily be the answer. Can you place some bigger element at any place? If you try to place a bigger element than x by n at any place, in that case, some other element would get smaller. So the GCD can never become greater than x by n. है ना? You can try to prove this thing. You will get it. Like it is simple to prove that the answer can never be greater than x by n. And for the part of proving it, just try to assume that if some element is greater than x by n, then definitely some other element would have to be less than x by n. So the GCD can never be greater than x by n. So for this part, the answer is simply x by n. You can get this thing, like we have got this thing very easily. But what if x mod n is not equal to 0? It is not equal to 0. In that case, what will happen? Like the case which we saw just now, that what if x is equal to 420 and n is equal to 69? I clearly knew that I can have something like 6 plus 6 plus 6 coming up 70 number of times to make a 420. But now I have to divide it into 69 numbers. So what I thought of doing is, what if I take 68 number of times 6 and then 12 at the end? Here in this case also, the sum is 14, like 420. Basically, I can say x is equal to nothing but, just assume that your answer is equal to g at the end. Then you can divide, like you can split x as g plus coming up till uh, n minus 1 number of times. And then at the end, you will have x minus um, g into n minus 1. Like the value of the last number would be equal to this. And since you know that whatever the answer you will have is gonna be, I think that it might become a little complicated for some people, but this is some learning part which we will see here. Just assume that your answer here is g, like the GCD of all these numbers is g. So you know that g divides this number, g divides this number, and similarly for all the numbers, g divides everyone, है ना? Since this is the greatest common divisor. So if GCD divides all of these numbers, then it would divide the sum of all of the numbers as well. So GCD will divide this number as well. This is just a claim. You should think of such observations as well. It might help, it might not help at some places, but you should at least think about this thing. So let's keep that thing in our mind for now. So you know that x minus this part should also be a divisor of, sorry, not a divisor, but a multiple of g. है ना? It should also be a multiple of g because this is a multiple of g and this thing is also a multiple of g. So the subtraction would also be a multiple of g. So if you like, we can have this kind of a pattern. Like we just figured out a pattern here. Just in case if you feel the expression to be too complicated at the moment, you don't really have to push yourself a lot. Like I would suggest that you should try to think about it, understand about it. But in case if you feel a pattern to be very complicated, there is no problem. The problem can be solved without generalizing things as well. Let me look at chat once. I tried the highest factors of 420 such that 421 factor is greater than. Uh, yeah, Sagar, we will do something similar to that. First, from the factors something greatest factor less than equal to. And, Okay, so my solution is also similar to the ones which you have written in chat. Okay, great. Let's come back. For those who got it, it's good. For those who didn't understand this, I would suggest you to try to generalize things like this. Otherwise, there's no problem. Just skip this part in case if you feel it complicated.
I have a doubt.
Yeah.
Can you explain it again, the last part, x minus g multiplied by n minus 1? I didn't get the g multiplied by n minus 1 wala part.
See, you know that the sum of all these elements should be equal to x. You know,
Yes,
if,
correct.
if you have 420 equal to 6 coming up 68 number of times,
I think that
then
would
what
be
should be the last
408.
element? Huh?
That would be 408.
Yeah, whatever it is. At the end of the day, the last element should be nothing but 420 minus this amount. Only then the RHS would have the sum equal to 420. You know?
Yes.
Yeah, that's what I was writing here. Uh, okay, I think that I forgot to explain this thing. Why I took x minus g into n minus 1 here. Okay, so let me tell this part also. So the thing which we did here is when we saw this kind of a pattern, we realized that if n was equal to 70, some divisor which is greater than the 69, like if I say n dash is equal to 70, some divisor which is greater than 69, in that case, I can easily say that I will split the elements in such a way that all the elements are equal to 6. है ना? I can do something like this. But here I have my n being smaller than this 70. N is smaller than 70. Specifically, it is 69. And what I want here is the GCD of like for the intuition purpose, you would have actually just thought that since there is one less element, what if I club the last two elements together? So I will have 6 plus like 6 coming up. I will have 6 coming up 68 number of times, or maybe 67 actually. Yeah, 68 number of times. And I will have a 12 at the end, such that the sum would be equal to 420. All these elements are equal to 6, and this one is nothing but a multiple of 6 because I have just clubbed up a few elements from the end. So the GCD will remain the same, right? Let me summarize this once again. What we have observed here, we observed one thing, that if in case if x mod n is equal to 0, if n is a sorry, if x is a multiple of n, in that case the answer is x by n. We just saw that why it can never be greater than x by n, and x by n is possible, so this must be my answer. Guys, please just tell me in chat that was this part clear, completely clear?
Yes.
Okay. After that, we talked about the case that what if x mod n is not equal to 0? What if it is something different? So for the example purpose, we took that x is equal to 420 and n is equal to 69. So what will happen here? We just wanted to know what will happen here. This was a test case. So you know one thing, that whatever you could get for x like n equal to 70, like the case where 420 was equal to 6 plus, like in case of n equal to 70, things were looking like this. You can get the same, you can get the same answer for n equal to 69 as well, because instead of having 6 coming up 70 number of times, you can have 6 coming up 68 number of times, and for the last two sixes which you had out of the 76s, you can just have them coming up as 12. So the number of elements here is 69 and the sum is still equal to 420. So the observation which we have got from here is uh, for n equal to 69, whatever answer was possible for any number, like anything like n equal to 70 or any number greater than that is also possible even now. Does this thing make sense now? So what we can say is, if you get something like x mod n, like x is 420 and n is 69, where x mod n is not equal to 0, you know one thing for sure, that one way of getting some answer can be that whatever you could get for the for any multiple, sorry, for any number, any divisor of x which is greater than n, or any n dash which is greater than n, can also be the answer for the current n. Uh, so Pratik is saying that I could have directly talked about this thing instead of that long one. Okay, so just in case if you think that I should have not discussed all this part, I think that discussing this one was also important. Like, I'm not really sure. It is we are no, we want that. Like, I don't really know. I think that this was the important part. If I didn't know about anything like this, if I had not tried to think about anything like this, then I would have never got the intuition for this part. Our
Yeah,
focus,
it
our
was
focus
really
here is
helpful.
to develop the intuition and not just go for the solution. Okay, anyways, let's just leave that part and focus for the problem now. So one thing which now is clear is the answer for any n would either be greater, like answer for any n would either be greater than or equal to answer of n dash, where n dash is greater than n. Does this thing make sense? We just saw this here, that whatever you could get for any n dash, you could just club up some elements from the end and you will get the same answer for n also. Okay, this looks good. Now let's go back to the problem. What we wanted is, we wanted to find out the maximum balance. The maximum balance, which is nothing but the GCD of the difficulties of the subproblems. So you want the GCD thing to be maximized. You know? So we want this part, like the 666, which was coming up, or to be more specific in the expressions, the part of x by n. If you remember, what we had done was, we had said x is nothing but equal to x, like x is equal to x by n plus x by n plus x by n plus x by n, and so on, for the case where x was divisible by n, right? For this part, we saw that we had to do something like this. We want this amount to be maximized because this is nothing but the GCD. So for that, you would want to have this thing at the dividing part to be minimum. है ना? So can I say, or can I say that I would like to have n to be minimized? And in this expression, that n is nothing but this n dash. Can I say this thing? That the lower this n is, the smaller this n is, the greater my answer would be. And this n should be a divisor of x here. So I want to find out, I want to have a small multiple, sorry, a small factor of x coming as n dash. Guys, are you fighting in chat? Guys, please don't fight in the chat and please focus here. So does this thing make sense? We got it from, like, there can be multiple ways of thinking about it. The one way I uh, chose to take for explanation is that x is nothing but the sum of some x by n we were taking for the case where x was divisible by n. So you see that if n is smaller, in that case x by n would be larger. And here, in the case where x was not divisible by n, we were taking some arbitrary n dash, which was a factor of n. So we would like to have that number coming up as small as possible. So what we have realized till now is, if x is divisible by n, then the answer is x by n. In the other case, you would like to say that the answer for this, the answer for this current case was this one. But for the other case, if x is not divisible by n, in that case, the answer would be something like answer of n dash, where this n dash is greater than n. And we saw one more thing, that the larger the value of n dash is, the smaller the GCD would be. So you just want to find out n dash to be as small as possible. And one more claim which we had done is, like, this n dash thing was divisible by x. So, like, if you try to think about the observations we have made, the small observations we have made, if you club up all of them, you will see that what we want to do is, we just want to find out n dash where it is the smallest possible factor of x, such that it is greater than or equal to n. So this is the final thing which we have realized after all that mess we created. The reason I didn't directly jump up to this part is because I wanted to cover the small observations which you make while solving the problems. That is the main learning part of the problem which we discussed up. Okay, so guys, are you with me right now? How many of you are with me right now, and how many of you are not? Okay, great. We can take all the factors. Yeah, so now the problem is a lot simpler from before. Now what we want to do is, we just want to find out this n dash, and once we find out this n dash, the answer is simple, like that. The answer would be x by n dash, where n dash would be the smallest possible factor of x greater than equal to n. So one of the ways for finding out this n dash can be, start from n till x and just check for every number one by one whether x mod this number, let me call this number as, maybe let me call this number as m. So just check for every m whether it is divisible, like whether it is a factor of x or not. The first number which you find out in this way, in the loop from, for let me call this I here, the first number which you get here from this loop would be the smallest possible factor of x greater than equal to n. And then you can just simply print the answer to be x by I, and that's it. So guys, does this thing make sense? And what do you think? What would be the time complexity here? The time complexity here would be nothing but big O of x minus n. X can be as large as 1e8. In the problem statement, they have mentioned this thing. And n can be as small as 1. So for every test case, you can have a 1e8 iterations. Like, not actually that much. You would not have the worst case in this case. But in general, you can say that the time complexity would be really bad here. Not really 1e8. It would be something better than that, but still it would be quite bad. And we have 1e3 test cases, so it will fail. We have to think about some different way. So one different way, it is a little conceptual thing, is that you can just find all divisors of x Just find out all the divisors of x, and after that, check for every divisor. Check for every divisor greater than equal to n, uh, and just store the minimum of all of these divisors. So for all the divisors which are greater than, for all those divisors of x which are greater than equal to n, just store the minimum of all of them. Store the min of all of them. Does this thing make sense? You can find in this way, you can just find out the minimum of all of the divisors of x which are greater than or equal to n. And once you figure this thing out, let's say I got it to be let's say I got it to be m, or maybe I got it to be s equal to the smallest factor like this, the answer would be x by s. Now, how will you find out all the divisors of x? And what is the time complexity here? For this, you could just notice, like, this is a standard thing, that if you have the number from 0 to x, all the divisors which come up, if there is a divisor, let's say 2 here, then x by 2 would also be a divisor. So if you just go on from 0 to root n, sorry, 0 to root x, check out for all those numbers in that range, and 2 comes out to be a divisor. In that case, x by 2 would also be a divisor of x. So you can just find out all the divisors of x in the range from 0 to root x, and then all the, like, once you figure out this, let's say if I is the divisor, you can just say that there would be x by I would also be a divisor, and you just got both the divisors in this range and this range, because for every divisor coming up somewhere around here, will have a corresponding divisor at this place. You can confirm this thing with some example. Let's say 2 is nothing but, sorry, 12 is nothing but 2 into 6. So if there is a divisor less than equal to square root of 12, then there is some other divisor which is greater than that also. And I hope that you would have already studied about this thing, maybe in school or maybe in your competitive programming journey. So this thing should be now easy. You can just traverse over from 1 to root x. For every divisor you see, you will have some other divisor. Just check out for both the divisors. If they are greater than n, then store the minimum of all of them, and then you can get the answer as this thing. Yeah, Mayank has written that in chat. That's correct. The number of divisors can have up to 1e6. Uh, I don't I don't know if there is some expression about the maximum number of divisors there, but in 1e8, like for a number of 1e8, if x is equal to 1e8, you would have to traverse from 1 till 1e4, which is the square root of 1e18. And for all these divisors, you will have some divisors here. So the time complexity for 1e8, for x being 1e8, would be nothing but like there will be 1e4 iterations. Like random ratio, it will be less than 1e8. Uh, I didn't understand what did you mean by this part. The last message you sent. Okay, so that's what will happen in the worst case if x is equal to 1e8. In that case, in the worst case, we will be having 1e4 iterations. And since there are only 1e3 test cases, the number of iterations would be somewhere around 1e7, which will pass, which is good enough. So here is my code for this. Uh, First of all, I'm taking all the test cases as input. After that, um, for every test case, I'm taking x and n as input. And initially, I just said that the smallest divisor of x which I know is x, which would obviously be there, है ना? Because I have to initialize it with some number, so I just initialize it with x. because the answer will never be worse than it. After that, I started a loop from 1, went it till square root of x. So for saying square root of x, you can either say it like this also, j into j is less than equal to x. And in case if the number doesn't divide it, then just skip. Otherwise, if the number divides it, then check. If this number is greater than or equal to n, then this might be the answer. So I will just say that s is equal to minimum of s and j. In the other case, the other divisor is x by j. So if it is greater than equal to n, in that case also, s is equal to minimum of s and x by j. And eventually at the end, I will have my answer is x by s, and that's what I will print. So guys, is the problem clear? Should we move on to the next problem? Okay, great. Let me open the next problem then. Okay, this is the third problem. In this problem, it says that you are being given two integers n and k along with a string s, and our task is to find out whether all of the possible strings of length n that can be formed using the first k lowercase English alphabets occur as a subsequence of s. In case if the answer is no, then we have to print the string of length n that can be formed using the first k lowercase English alphabets and does not occur as a subsequence of s. And in case if there are multiple answers, we can print any one of them. So this is the problem. And here n would be less than equal to 26 and k would be less than equal to 26 and m would be less than or equal to 1000. And over all the test cases, n and m, like the sum of both of them would be uh, less than or equal to 1e6. So I hope that the problem makes sense. Uh, the problem makes sense. We just did the first a problem earlier in which we had been given some string. We were being given some string and we had to tell whether, sorry, we were being given n and k and we had to create a string. Now it is like you have to design a way of confirming whether the string actually contains all of the given strings or not. This is the way I think the problem setter would have and realized the problem, that he would have to write up a solution for checking whether the string we gave was correct or not, and he would have proposed it as the solution as a new problem. Basically, we have some integer
Oh,
n, k, and a string
sorry,
s. Yes,
joined a bit late. Which problem is this?
this is the C problem.
Okay, okay. Please carry on.
Okay, thank you. So we have been given n, k, and a string, and we have to check if the string s contains all of the strings that can be generated of length n with the first k English lowercase alphabets. Whether all of those strings are coming up as a subsequence in the string s or not. In case if there is any string which it is missing, then we have to print that string. So it is kind of like writing up a solution to validate the string s, which somebody could have printed as the solution, whether it is correct or not. So it is kind of a problem like that. We have to validate if this is a valid answer for the problem A or not. Something like that. You can think about it. So let's come back to the intuition we had got for the first problem. We had noticed a pattern like the first k alphabets coming up together, then the next k alphabets coming up together, and so on. We did notice that if there is a string like ABC, 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 and ABC, in that case, it will have all the substrings, sorry, all the strings of length 4 coming up with first three English lowercase alphabets. We did notice this part. Right? Do you guys remember that? Yep. Now what we have to do is we would be given some string and we will have to find out whether there exists any string which cannot come up as a subsequence of the given string or not. We have to find this thing, and in case if there is, then the answer is no, otherwise the answer is yes. So can I say that I will have my focus in this problem as the focus of mine in this problem will be to find a string which does not come as a subsequence in string S. Can I say that I will try to have my focus on this thing? In case if I succeed to do so, then I will print no and the string I got. In case if I fail to do so, then I will print the answer as yes. So I have just manipulated the problem a little bit for my convenience. Now my aim is to just find out a string which does not come as a subsequence in string S. For this, I try to think about multiple ways. Like I tried to think of multiple things and got some intuitions from some places. This was one of the intuition that if there are this kind of blocks, what I say a block is, I would say that some alphabets coming up together, maybe something like this also, where all the first key English alphabets are coming. If I say this thing as a block, and there are over n blocks, if there are n blocks in the given string, in that case, it would always be possible to create all such strings of length n having k number of like having the first k alphabets. This thing would always be possible. And actually, we saw this thing in the problem A also. Now, what I wanted to do is I wanted to find a string which doesn't come there. Let's take an example. If there is a string like ABB, AABB, CC, and ABC, something like this. I want to find up a string which does not come with length 3 and k equal to 3. In this case, I want to find the answer. So there are multiple ways in which you could try to think about it. Is this necessary and sufficient? Yeah, like this thing is, I think it is necessary also, and it is sufficient for sure. For now, let's come back to this part. How many blocks do you see? The first block I see is this one. You cannot have a smaller block. And the second block I see is this one. Because if you try to
Uh,
think,
Sorry,
yes,
a quick question. Like, what is your definition of block? Because up till C, you could have managed to do it up till the previous C as well, right?
oh, sorry,
The
sorry,
way
sorry,
you have,
sorry, 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 my mistake. My bad. Good point. I could have had my block till here. Yeah, sorry, that was my bad. These are the two blocks. So what I said was, I said a block has like this is not any standard thing. I'm just naming it for the convenience of explaining. I call a block as some segment of string which contains all characters, which contains all k characters, like this one. It contains A, B, B, and C. So A, B, and C are all coming up in this. Then this is the second block in which all A and B and C are coming. So if I have something like, if the string I create has something like any character of A, B, or C as the first character, then any character of A, B, or C as the second character, you can easily find up a subsequence. Maybe if I have a BC, then B, and then a C. For the third character, if I have a C, like all these substrings can definitely be created. But if I pick up a string like C, B, B, like A and B are not coming in the third block, there is some possibility that this kind of string might not come in as a subsequence from this string, right? In this string, try to find a subsequence which contains CBA. You will see that there is no such subsequence, right? Let's have 5 seconds, five
I
more seconds.
sorry, I did not get why like how did you claim that construction of such a string is not possible?
Uh, like try, I just said that try to find a subsequence here. We will see that why I picked up CBB only, but try to find out if there is any subsequence inside this given string CBB. That's our motive. We just want to find up a string which is not a subsequence of this string. I know. We will
Yeah,
see
yeah.
that for the first C, you are forced to pick up this one. For this B, you are
Okay,
forced to
okay.
pick up this one. And for this B,
Nice.
you don't really have any choice. I know.
Got it.
Now, in case if somebody did not understand this block part, what I was talking with this block thing, then you won't understand the problem. So please confirm me once whether all of you got what do I mean by a block, or is there anybody who did not understand this? Then we will go ahead with the problem. Okay, seems like all of you got it. Great. Yeah. So um, the thing is, just imagine that if I take up a string where I say something like, okay, one more thing. Did you guys get that why it would always be possible to create any subsequent any string in which the first character can be anything, second character can be anything, and the third character is C? Did you guys get it that why is it always possible? It is always possible because we have a complete block. We have a block with 3 elements. So we have a block with having all the 3 characters. So whatever the first character is, I can just pick up one of the elements from the first block. Then for the second element, we can just pick up the desired character from the second block. And for the third element, we can just pick up, like if it is present, we can just pick up. If it is C, we can pick up. But if it is something like B, we cannot pick it up from this block. But does this mean that any string which contains any first 3 characters, sorry, yeah, does this thing means that all the strings where the first 3 characters can be anything, sorry, first 2 characters can be anything, and the third character is either A or B, will not be possible? Does this thing holds? You can try to think about it, but you will see that it doesn't hold. Because if you try to think about a subsequent a string like A, B, P, it does come here. A, B, B. In fact, it is even coming up as a substring. Why? Why is this thing uh, holding like this? It is because once you say that you want a string like ABB, you took the first character. Now you just want to have BB from the remaining string, which is ABB, CC, ABC, right? From this part, you just want a BB. You see, now this portion is like a block, and this portion is like a block, and this portion is like a block. So it, sorry, not the third one. These two are like blocks. So it is like you are having 2 blocks and you want 2 characters. So it would be possible. I know it would be possible. So we just uh, understood one thing for sure, that what we have understood for now is if the number of blocks is greater than or equal to n, the answer is just print yes. If the number of blocks is less than n, there might be some string, there might be some string, or there might, like we just notice one more thing, that we cannot blindly write any string. If we just blindly write any string like AB, it might not be there. We have to be smart. है ना? So let's see how we could have been smarter. If we had that exact same string ABBCC ABC and another C coming up, no, sorry, it was like this. And earlier I said that these are kind of blocks. If I had said that I want a string in which the first character is C, so in that case, I'm making sure that the last character of the block would be chosen. All of these characters are now wasted. है ना? I can do something like this so that I do make sure that the whole block is being wasted. The whole block is being wasted for this first character. Now for the second character, I can pick up this B so that I make sure that none of these characters can be picked now. And for the third character, when I know that there is no complete block left, I can just pick up any character which is not there in the block. So either A or B. है ना? Something like this. Now this string would not be there in the given string as a substring. So guys, please tell me this part that does this make sense? Does this way, like the smart way, uh, are you at least sure that it will definitely give me the correct answer? How do you define the size of a block? The size of a block can be different. What I want is that the only thing from the block is it should have all the first k characters. If a string is something like a coming up too many times and then bc coming, so this would be my block. What I mean by a block is nothing but I just know that it contains all these characters. It contains all the k characters. Like there can be different
Uh,
ways. I just try to tell about the way I approach the problem. Yes, I can
so
see.
how did you append the so I got it that for all the complete blocks you're picking the last character because that is how we have defined the end of a block.
Yeah,
Um, but but the after this you are deficient. You will be deficient. You'll be deficient, right? Because you have to make a string of length n, and let's say n was 3, and you have made CB up till this point. And what is your decision to pick A to make it 3 length string
yeah. See,
that you have to return?
for the first two blocks, you know that you are right now just considering the cases where the number of blocks is less than n. In case if it was greater than n,
Yes.
then you would not really worry about
Then
what to
it's
do.
yes.
The answer would have
Yeah.
easily been yes. But if it is less than n, first thing you are doing is definitely just picking up the last characters of the block. We know
Hmm.
why we are doing this because we want the whole
Yeah.
block to be not reusable anymore. After that,
Correct.
let's say you got m elements. Maybe just imagine that there were n minus 7 number of blocks. You want 7 more characters. है ना?
Yes.
Now the thing which I'm saying is there after the end of all the blocks, there must be at least one character which is not coming up in the rest of the string. If there were all the characters coming up, there would have been one more block. है ना? But if there is no
Correct.
block anymore, then it means that there is at least one character which is not coming. Just find out
Hmm.
any one of those characters which are not coming at the end and pick it up. And once you pick this up, now it doesn't matter what character you place after this. So what I did is
Okay.
just placed up that exact same character until the length of the string became. So here it became equal to n was 3. So I just stopped here. That I got the string which is not really coming up in the whole given string as any subsequence.
Okay.
Okay, so
Like I'm trying to think of a counter example here because
yeah,
the CB
that's a good thing.
thing because the CB thing that you have said like yeah, it forces us to come to that particular index, the second pointer that you're pointing to. But it so happen that can it so happen that the CB thing comes somewhere before, and this A that we are appending, the third A that
Okay,
we appended at the
let
end.
me show one more way of just verifying that this can never come the way we said.
Okay.
You see, this first character which we have used is like it would in the given string for the subsequence, you would always pick up the first occurrence. Obviously, you will never pick up
Okay.
the occurrences which are coming later on. You can try to think about it. It is always beneficial to pick up the first occurrence. This can be proved also. After that, it is like the problem has got reduced. Now you have this as the string, and you have to pick up some more characters. Now again, you are just picking up the character which is like among the k characters which is having the first occurrence at the latermost
First
position.
one.
है ना?
Correct.
In this string, the character C had its first occurrence at the latermost position. A had first occurrence here, B had its first occurrence here, but C had the first occurrence coming at the latermost position. So you just pick this up.
Yeah.
है ना? Now all these can never be
Yes.
used. You got
Correct.
the string to be reduced as much as possible. After this, you
Yes.
wanted to pick up B, like sorry, not just you didn't know what to pick up. You see that C is coming first, A is coming here, B is having the like largest first occurrence, the rightmost first occurrence. So you will pick up this guy now. Because if you pick up A or C, any of them, then it is just words for you in that case. Picking up B is canceling the maximum number of elements, which cannot be used anymore now. That's why you will pick up B.
Yeah.
You know, after that, you just saw that there are some elements which are not really available in the string. So if you pick up any one of them, it guarantees you that it is not possible to get any subsequence like this for now. Now it is guaranteed because you have just seen the complete thing, that when you chose this first character, you just got rid of all these characters. You don't have to
Mhm.
think if it is possible to pick up anything else from there or not. When you picked up this B, you just got rid
Yeah.
of all this.
Yeah. Correct. I think it's a
This
simple contradiction argument that if at all such a thing would have existed, then
Yeah,
the last occurrence that we have taken would not have been last occurrence in the first place.
yeah, one more thing.
Um,
Yeah, that's good
because
thing you are saying. If this A would have been there, this is just a contradiction, that if this A would have been
yeah,
possible there, then we would have never picked this guy. If we are only picking this guy because we know that A is not coming, right?
yeah, okay.
So
Actually, sorry, I did not get this last thing that you said. A we are picking because it's not available in that block, the third block. That's what you said, right?
yeah,
Uh,
yeah. If A was also
and
there, then we would have picked up B. And just imagine if B was also there, then we would have said that there is one more block. You know,
yeah, and then it would not have qualified as blocks less than in Walla case
what?
because uh,
Like what
because
did you say?
if both C, so if C and C A and then B, the one that you can undo the previous thing that you have written. If that were there in the place, then the blocks would have been equal to n, and uh,
Yeah,
we would not
yes. In this
have
case,
this
the number
case.
of blocks would have been equal to 3.
Yeah.
So just in
So,
case if
hmm,
n was equal to
nice.
3, then the number of blocks would have been same and I would have never
Yeah,
come here. If the number of blocks, like if the value of n was greater, let's say if n was equal to 5 here, and this was the string, then in that case, I would have seen that the like after the third block, there is no character. All the characters are absent. So I could just say something like AA there and get a string like CBAAA, which is not present.
okay, got
You
it.
know, after the first 3 characters, just pick up anything which is not present, and after that, it doesn't matter whatever you say because the string would not be present. So guys, does like is this problem clear now, or is there anybody having any doubt? Okay, so let's see the code. So my code for this problem has been like this. I've For every test case, I'm first of all taking nkm and the string as input, where m is the length of the string. And for maintaining, I'm maintaining a set to just know which characters have come up for the current block and which have not. So I would go in this way. I see this A, I will include A in my set. Then after this, when I see the B, I will include B in my set. Then once I see the C in C, I will include C in my block in my set. And as soon as my set, the size of my set becomes equal to K, it means that the block is completed. The first block is completed. So what I'm doing for my in my implementation is I'm emptying the set. I'm saying that now the set is just empty back again, and I'm pushing the C to a string with name answer. I'm having a string with name answer in which I'm pushing the C, because if I will have some answer in this, the first character would definitely be C. And then I just repeat the same thing for the rest of the string, like adding C to the set, A to the set, B to the set, adding CAB, and then last set is having a size K. So make it empty, and the last character which you had pushed, that is B, just push it to the answer. At the end of the day, the size of this answer would be the size of the string answer would be nothing but the equal to the number of blocks. So if the number of blocks at the end, like it would be nothing but answer dot length. So if the answer dot length is greater than or equal to n, then just print, if this thing holds, then just print yes. In the other case, if the number of blocks were less than n, then I just wanted to find out some character after all the blocks which is not coming up. Let's say if there is a C, repeat the step. Okay, so you want me to repeat this step, Mukesh? Answer. Okay. See, what we earlier saw is we wanted to make blocks. We wanted to make blocks, you know. So I said, just to like, how will you make sure? For this, what do you want to do? You just want to make sure that all the first key elements have come or not. You want to keep track of this. How will you keep track of this? There can be multiple ways. One of the ways is just maintain a set. Let's say you get A in the string, just push it into the set. You got A, it is already there in the set. You got B, just push it. You got B, it is already there. You got C, just push it into the set. Like do like this. And as soon as you see that the size of the set you have becomes equal to K, so you know that the block is complete. The new block will start from now on. So just empty the set for the next block. And since the first block has ended, what did we want? Like we wanted to keep track of the last element of every block. So you can just have a string with name answer, and inside that you can push the last character of this block. You can do this thing for all the blocks. Like for the second block, you will just see C, add C to the set. You saw A, just add A to the set. You saw B, just add B to the set. And the size of the set became equal to 3, which is the value of K. So add B to the answer and empty the set. And repeat this till the end of the string. So in the end, you will have C into the set. The answer string would be CB, and the given string would have been completely traversed. Now you know that the number of blocks you would have covered every time you would have pushed some character into the string answer. So this answer string, like if you just look at the length of the string, you will get the number of blocks you covered till now. If this thing is greater than equal to n, it means that you got more than n blocks. So the answer would be yes. In the other case, in the else case, if the length was less than n, it means that you have got only n minus 1 or less number of blocks. You have not covered all the blocks completely. So from the characters you got after the last block, other than any of these characters, you can pick up any character. So what you can do is you can just go on from for all characters from A to um, A plus K, like just find out the A plus K minus 1. For the from the first K characters, just check out for every character which one is missing in the set. And once you find out the character which is missing, let's call it as missing, that character is missing. Now, while answer dot length is less than n, you can just say that, hey, answer dot pushback this missing thing. You can just push this missing character into the end of the answer as long as the length of the answer is less than n, because we have to print the answer with length n, and then at the end just see out answer. Like this is the way I did implement it. You can have a different implementation as well. There is no problem in it. So this is how I did code. For every character, I just push it inside the set. In case if the set size reaches k, then I said that push this character into the answer string and clear the set. After that, if the answer dot length is greater than equal to n, it means that you have got more or equal to n number of blocks, then the answer would be just yes. Otherwise, you can print no and just find out a character which is missing inside the set. And once you find the character which is missing inside the set, you can push it inside the answer, and after that you can push out any element. I just pushed that exact same element forever, and after that just print that string, and that's it. The test case is done. Okay, that's good, you got it. What about others? Did is it clear to everyone now? Okay, great. Let's look at the fourth problem now. The fourth one is a bit difficult, or at least quite mathematical. I don't really understand it completely either. So this is the fourth problem. It says that there are n children in a class. M pairs among them are friends, and the ith pair who are friends have a friendship value of fi. The teacher has to go for k excursions, and for each of the excursions, she chooses a pair. Like they have just given some story. The basic idea is there will be k pairs, every pair having two children. If the pair of the two children are already friends, then their friendship value increases by 1. Otherwise, the friendship value, in that case, the friendship value increases by 1. Otherwise, um, if the two people the teacher chose are not friends, then nothing happens. Their friendship value doesn't increase. And is there anything else also? Who are friends increases by 1. For all the subsequent excursions, the teacher can choose a pair of children more than once also. And yeah, in case if the pair is not really present, if the two characters, the two people the teacher chose are not friends, in that case it doesn't change anything. And we have to find the expected value of the sum of uh, friendship values of all k pairs chosen for the excursions at the time of being chosen. So let me take an example here. If there are pairs, like let's say there are two people. Obviously, since there are two people, the two friends would be only 1 and 2. If there are one friends, like let me see. Yeah, let us say n is the number of people, which is 2. There are two people, and there is one pair of friends, that is 1 and 2 are friends, and there are two excursions. In excursion, nothing happens, just two random children are being chosen, and if they're friends, then their friendship value increases. And the friendship value of 1 and 2 is 1. Let's say something like this happens, like this is the problem. then what will happen? Initially, the answer would be 0. The sum would initially be 0. These two friends would be chosen one by one, and like together. The friendship value would be 1. So 1 would be added, and the friendship value will now become 2. Now, the next time these two friends are being chosen in some excursion, in the sum, 2 would be added since 2 is the friendship value, and this will also increase. The problem is something like this. Let me confirm this one. Yeah, the problem is this only. Now, till this point, it is simple. There is no problem. If you have to see how to find out the sum of uh, the friendship values of the k pairs. But the thing is, we have to find the expected value of the k pairs, like for all the possible pairs which could have chosen, all the possible combinations of the k pairs which could have been chosen. Among all of them, we have to find out the expected value, where every pair can be chosen equiprobably, randomly, and independently. Like it doesn't matter which was the last pair being chosen, the pair can be anything, and the pairs can repeat. So let me mention the prerequisites first. The prerequisites are, first of all, probability. You should know about it a little decently. Then the next thing is expected value. You should know how to find, like, what is expected value and how to find this thing. You should know about this also. And you should be good at, okay, one more thing. You should know about modular inverse. And you should be good at overflows, like taking care of overflows, or maybe handling overflows in integers. Because if you don't know how to handle overflows, and if you don't know how to handle overflows properly, then you might make up some mistakes. Though these three are the concepts which are important. So what we have to do is we just have to find the expected value, and at the end we have to, like, if the expected value can be represented as an expression of as a fraction p by q, then we have to print p into q inverse mod 10 raised to the power 9 plus 7, where this q inverse is the modular inverse of q. Probably if this is the first time you are seeing something like this, it might not be simple for you. And sorry, but I'm not really good at math, so I won't be able to teach here anything. I would not teach much and not teach anything, because I might just teach some weird stuff or maybe some wrong thing. So let's see one thing. For expected value, as much as I remember from the thing which we studied in colleges, it is something like summation of possible values of the events and their probabilities. Like if you roll a dice, the possible events which can come are the values which can come are 1, 2, 3, 4, 5, 6, and the probabilities are 1 by 6, 1 by 6, 1 by 6, 1 by 6. The expected value is nothing but the sum of all of them multiplied with their probabilities, and then the sum of all of them. So I think it should come around 3.5. So that's what you actually expect also. You expect the time complexity, the expected value to be something like average here, in the case where every thing has some equal probability of coming up. Here in this case,
It's just the weighted average. That's all. The weight is just the probability.
yeah, that's also some way of saying expected value. This is the weighted probability or average of probability, something like that.
Weighted average, not
Yeah,
weighted
weighted average
probability.
of probability. Anyways, let's come back to the problem. Like I would be honest that I don't really know about it completely. I didn't prove anything. I just did it with the obvious things which were coming up. I just saw them and tried to come up with some solution. It did work, luckily. The one of the obvious things was that if there are n people, then there are nc2 number of possible ways of choosing two people. है ना? Let me call this thing as mx for now. This is the this is the number of possibilities, the number of pairs you could have chosen, and we will be choosing one of the pairs with equal probability randomly. There are m people, there are n pairs of friends. है ना? There are m pairs of friends. So there is m by mx. This is the probability of answer as increasing. Sorry, not answer, but the friendship value of increasing. The probability of uh, increase in the friendship value is this much. And what is the what is the expected value of the friendship value you can get in one turn? Let's be clear about one thing. If one is a friend with 2 and it has an expected value of 3, and one is a friend of 3 with an expected value of 4, it doesn't really matter which pair of people are friends with what expected time complex, with what friendship value. Even if it was something like 4 3, the answer would be same. You can verify this thing. And I just assumed this, like I was just getting some intuition that even if
I
instead
have
of
a
this,
question.
yeah,
Sorry to interrupt again
yeah,
and
no
again, but
problem.
I really want to solve this problem today itself. So, the you have just calculated the probability that in an arbitrary excursion you are choosing a this thing, a friend pair, right? And that comes out to be m by mx, irrespective of whatever the fi value be. The fi is the friendship value, the ones that you have written 3 and 4, right? So
Yeah, we have not talked about
irrespective
the
of
friendship value
three,
in this case. We have
okay.
just
So one,
we are just saying that this is the probability of getting a friend pair, and if we get a friend pair,
correct,
then in that case, this is the probability. Basically, this is the probability that the value of friendship pair will friendship values will increase.
increase, but how much it will increase, that depends which particular pair gets chosen, right?
Yeah, we are talking about the pairs now. So this
And
is,
so can we assume 3 plus 4 by 2 on an average, uh, which is 3.5, is the weight here with the probability m by mx?
yeah, actually this is the thing which I did also. I was just sure about one thing, that it, like, for since all the pairs are equal for me, it doesn't matter if one guy is having value 3 and the other is 4, or the other way. If this pair had a friend value of 4 and the other pair had a friend value of 3, it doesn't really matter. And one assumption I made here was that even if the friend values were like this or were like this, it doesn't really matter, because eventually what will happen is the probability of this guy coming is nothing but m by mx. No, sorry, 1 by mx, and the probability of this guy coming is also 1 by mx. So in one turn, when I choose some element, every guy is having the probability of 1 by mx to come, and it has some friendship value. So it is like if this pair had a friendship value of f1 and this pair had a friendship value of f2. So in one turn, I can get something like uh, expected value is nothing but the weighted average, right? The value into probability, the sum of that thing. So here the value is f1, the probability is mx, that is nothing but nc2. Similarly, for second guy, the value is f2 and the weight probability is 1 by mx, so f2 by mx, and so on for every guy. You know, for every guy, this is this. Like this is the expected value you will get out in the current excursion. This is the expected value for the current excursion. Sorry, this is fm here. And you can just take out mx common in all of them. Just take mx column common in all of them. So what you're getting here is the sum of all of them. This is nothing but sum f. Let me just use a variable sum f here. So in one turn, you are getting sum f by mx. This as the value in excursion. This as the friendship value, expected friendship value in one excursion, right? Does this thing make sense? Like I did it mathematically, so it should, I guess.
Yeah, this makes sense, but like I'm not okay.
Yeah.
Maybe you can go over your explanation. I have some questions at the end.
Okay. So at least this part makes sense, that we have understood what is the expected value for
Yes,
one
this
excursion.
this
And
this makes sense.
when this thing comes with the probability of m by mx, one of like m by mx is the probability of uh, getting one of these friend values being chosen. In that case, let's say that the second friend pair is being chosen, its value will increase by 1. है ना? It can happen with this probability. So eventually when you will like you can try this out later on, you will see that if I just say that sum f, which like sum f is increasing by this probability, if I say something like this, it won't make any effect, because uh, like in any of the cases, if one of these is being chosen, at the end I will divide it by mx. Nee. Sorry, I think I just messed up at this place. Let me go back. Let's go back. We just saw that when you will get one thing chosen, when you will see that one thing is being chosen, if one of the pairs, if one of the friend pairs is being chosen for the excursion, its value will increase by 1, and there is a chance of m by mx for it to be chosen. So let's see. Yes. Yeah, it has a chance like this. So during the contest, to be very blunt, I just assumed that overall I can just assume that uh, every of guy is getting an increase of 1 by mx. I just said that every pair is getting an increase of 1 by mx if this is a friend pair. Like we can say this thing, that on an average you have a probability of 1 by mx to be chosen for every friend pair, right? And if it is being chosen, its value will increase by 1. So on an average, if I just I just assumed this thing, it might not be mathematically correct, and I just came up with an idea that what if I say sum f is increasing by m by mx, because there are m friend pairs and every friend pair has is gonna be, its value is expected to increase by 1 by mx. So this is kind of an assumption. It might not be mathematically correct way of doing this thing. For this, I would suggest to look at the tutorial, but I had this idea. So for for every excursion, what I did is I just increased the value. I just increased the sum by sum f minus sum f by mx. We just saw that this is gonna be the increase in excursion, increase in friend value after the excursion. This is the expected value, and the expected increase in the value of the sum of all of f is nothing but m by mx, because 1 by mx is expected to increase in all the friend values. So for every excursion, I'm one thing I'm doing is increasing sum f by mx, the expected value for current mx, current excursion, and the expected increase in every like overall for all the friend pairs is m by mx. So I increase that thing, and I just brute forced it for all the excursions. Basically, I just did run up a loop of I equal to 0 to k. Now I'm like clear at this point that this might not be mathematically correct. It might have some inaccuracy. So I would suggest you guys to go to the editorial ones. In case if it is wrong, I will just mention it in the comment section. So this was my idea for this problem, and to make sure that you can store to just make sure that m by mx or this divide stuff you are not messing up anywhere. I did use a struct, like you will see this kind of templates where people name it as mint or mod and something like that, and use it. It just takes care of all of this like overflow stuff. So Abhishek, you had some doubt, like you wanted to ask something.
Yeah, so yeah, so when you said, so can you scroll a bit up in the
Yeah.
slide? So here, no, in the common part that you took and the F1 plus F2, so on, those things you just factorized. Just
uh,
scroll a bit down.
okay, this one.
Yes, no, just a bit down. F1 plus F2 plus so on up till Fm. Yeah.
This one.
So yes. So according to the expectation formula that you wrote, which is correct. So this the 1 by mx is the probability, and it interacts with all the weights which are F1, F2, so on up till Fm. Um, and because of this structure, you took the 1 by mx part out. What I feel is what you did was also mathematically correct, because here there is an invariant in the question, that is the sum of all friend values is no matter which pair you pick, it always increases by one. So the
Yeah.
sum, you need not have to track which particular excursion pair you took,
Yeah.
because
Mm.
because of this very fact that you have written. It anyway it gets factorized. The invariant at every excursion just gets increased by one. The sum just increased by one, and it always interacts with 1 by mx as the probability value. So everything that happens is within the the bracket that you have written, just increase by one at
Yeah.
every, and the way you are coding it up, it inherently gets affected there. Like, so the maths falls in place actually.
Yeah. I just want to be on the safer side, so I just said that it might have some mathematical inaccuracies, but at the end of the day, like even if it is having, the intuition is something like this. Okay, so like anybody having any doubt, or should we move on to the code part?
Yeah, I would like to look at the mint part.
Okay, so for the code part, one of the things is I'm using a structure like this one. Like you can just see search about this on internet or look at any grandmaster's code. They Everyone uses a structure like this mint. uh, Basically you can just think that instead of creating your things which can overflow, or anything which can overflow, just
Okay.
created with structure mint, and then you don't have to worry about overflows or something like this expression. You don't have to worry about this expression. It will automatically take care of convert this expression into this expression. I'm not
Okay.
covering up how it does, just it
Sure.
does. You just copy paste from Grandmaster's code and you can use it, or take up a
So
look
which
on how it
which
does.
which scenarios you think of using this, like where it can overflow?
Like this one. Uh, Here
The
the
main
expectation.
part.
See,
Okay, okay.
whenever you see something like this line, I don't even
Uh-huh.
think twice whether there can be any overflow somewhere else or not. I just use
Got
this uh, structure. One of the places where I can see that overflow can happen is this place. P into
Mm-hmm.
Q inverse can be greater than 1e9 plus 7 also,
Correct.
or even at this place where I've been writing n into n minus 1 by 2, there can be some of overflows if n is huge. No,
So just
I don't have to,
typecasting it next kid.
yeah, I don't have to now worry about any overflows anywhere because I'm using Mint. So for every test
So
case,
this
I'm
is all.
taking n, m, and k as input. And after that, we do have some friend pairs, A, B, and F. But as we discussed earlier, I don't really care which pair it is. I only care about the friendship value. We saw that only friendship value
Yeah.
was having some contribution. The people were not really having any contribution.
Yeah.
So that's why I will uh, not store A and B and only take care of F. Just find out the sum of F over all the test cases because I only cared about the sum of F, not even the exact values of the friend values. And I did create a variable with name mx, which is actually having the possible number of pairs, that is nc2. And
Yeah.
here I am having a variable with name answer, which is initialized with 0. And after that, for uh, for k excursions, I'm having a loop of k size. And for every excursion, as we saw that the possible increase in your uh, sum of friend values can be sum of friend values divided by mx. This is the expected increase, and the expected
Yeah.
increase in sum f is nothing but m by mx because this is the probability of some friend value pair being chosen. Sorry, some friend pair being chosen for the excursion, and we repeat this thing for k excursions, and at the end we just print the answer. So, any doubts, or can we end the session?
No doubts.
Okay, great. What about others?
Can you please send the code, please? The mint.
Yeah, you will get that in description in the YouTube video.
Sure.
I can share this in chat also after the session.
So if you can share it right away, I will just code it. I will be coding it up.
Yeah, I'm sharing. I'm sharing it. So for now, I'm ending the session, like recording.